So before we talk about or move on with the trigonometry, let's take a second to talk about ratios. I want you to not overthink ratios. People hear this sometimes and get a little freaked out. All a ratio is, and this is it, just two numbers written next to each other so you can kind of compare the two numbers. So could be something as simple as the price of gasoline. It's $2.73, and usually it's written as a fraction, for every 1 gallon. There's a ratio. Let's say you have a ratio of 2 to 1. So for two, I don't know, maybe you go to a university that's mostly guys, and there's 2 guys for every 1 girl. There's a ratio, 2 to 1. Of course, there's a lot of ways to write that. That 2 to 1 ratio, I usually think the university consists of 2 guys and 1 girl. It's not much of a university, is it? See, ratios, this though is easy to wrap your head around. If it was 7,000 guys at the university, then there would be 3,500 girls at the university. It's the same ratio basically, but written with different numbers. So sometimes the ratio holds the same, but the way it looks or way it's presented is different. I'll give you a common example. So let's say you get 270 points out of a possible 300 in a class. Well, there's a ratio. Well, you could look at that as even 27 over 30, right? 27 compared to 30. But most people are going to put it in a way that is common or familiar to them. And what way is that? You can probably already guess. They're going to say, well, I want to know what would it be out of 100? 27 out of 30. I think that's pretty good, but if I look at it as a 90 out of 100, then that makes even more sense, or even better sense to me. So this, see, all percent is the same ratio as this, the same as this. All a percent is a way of writing a ratio, and everybody uses it. So we all get established, or generally as we grow up, we get a feel for what 90% of something looks like. And then we base our grades in, but you don't really get 90 points out of 100, you get 270 out of 300. So this idea of ratios is going to be very important. And one of the places that we're going to see it is in the trigonometry. And we're going to build to it. There are certain ratios that have certain names, and we'll get to them later on. Before we name them, let's get a feel for ratios and triangles. So here's one situation. These 2 triangles have identical angles. I can't remember exactly what they are, but angle I and angle P, we'll say, are the same. And angle J and angle Q are the same. And angle K and angle R are the same. So what this means is that the triangles are basically the same shape, but they're scaled up or down. This one's a larger version, we'd say, of this. And there's a ratio here. There's a bunch of ratios that should work out to be the same. They may look different initially, but they should be the same. So, for example, the ratio of this side compared to this one. So the ratio of, we'll say, IJ, ratio of IJ compared to JK. It's a way of looking at that length. That ratio should be the same as this ratio, the one between PQ and QR. We call these similar triangles. They're very, very similar in shape. In fact, they're identical in shape, but different in scale. One's bigger than the other. So, but those ratios should stay the same. Now, one of the things you're going to have to get good in this class is measuring. In particular, measuring in the metric system. So let's just take a moment and do this. So in the exercises for this, I have you measure, and in centimeters. We don't usually use centimeters in physics. We use meters. So I'm going to describe this in both ways. But in this case, this is going to be, if I look at this carefully, it's going to be 6.9, so 6 centimeters and 9 millimeters, so 6.9 centimeters. But in physics, we don't use centimeters. Chemistry, they do. We don't use centimeters. We would use 0.069 meters. This is the way we would write this number in physics. Centimeters is 2 places over, so keep that in mind. This side here, if I measure it, I get, let's call it 6.6 centimeters, or 0.066 meters. And while we're at it, let's just do this side here, even though it's not part of our current problem. That's almost exactly 8. So we'll call that 8 centimeters, or 0.08 meters. So meanwhile, over here, for this triangle, we would have 4 centimeters, 3.85. I'm going to be a little adventuresome there. 3.85 centimeters, which would be, of course, 0.0385 meters. This would be 0.04 meters. And 4, I'll call 4.8. Is that right? Yeah, 4.8 looks good. 4.8 centimeters, or 0.048. Now, I measured all, but let's take a look at ways we could do it with find things without measuring. So, for example, if I know, let's compare these two ratios. Let's look at this one. So we'll do 6.9, there's IJ, over 6.6. Now let's just see how that compares to if I really did make these similar. These ratios should come out to be the same. This would be 4 over 3.85. So if I do 6.9 divided by 6.6, I get that to be 1.05-ish. And if I do 4 divided by 3.85, I get 1.04, so we're going to say with pretty good considering the measurements. So these two ratios are the same because these triangles are similar. And you can use this fact to find things out. So for example, one of the most common ways to write similar triangles, easiest ways to write similar triangles, is like this. Is to make one triangle, which by the way I've made a right triangle. It doesn't have to be, but in this case. And then just draw these 3 lines. Each one of these triangles, L, N, M, the little one, is similar to L, P, O, L, right, that one, which is also similar, they're all similar to the big one. Okay. They should all have the same ratios. So we can use this fact to find different values. So for example, if I had the overall length of this entire thing, right, and that was 15.7 centimeters. We'll stick with centimeters for now. Numbers are a little easier. And I had this side, 3.9 centimeters. And let's say I had, well, could I find this side? And your answer is yes, with the Pythagorean theorem from the last video. So I could actually find this side if I wanted. So I could have all 3 sides of this triangle, or I could measure it, but let's say for now I don't have that. And let's say I have one of these sides. So let's say for the little one here I have 5.1 centimeters. So then for the little one, could I find, put the ruler away, could I find this value and this value here for the small triangle? And the answer is yes, I can use the ratios to do that. I could say, for example, this is the hypotenuse for the little one. So 5.1 centimeters compared to, let's say, mn, the unknown. Let's set up the same ratio for the big triangle. Its hypotenuse, 15.7, compared to its little side, 3.9. And then the only thing I don't know is the missing side, mn. Now when we solve this, called a proportion, we solve it, we cross multiply. It's one way to do it. So I can say 15.7 times mn, switch to a slightly darker pen, equals 5.1 times 3.9. So I have 15.7 mn equals 19.89. I can divide both sides by the 15.7. And mn will come out to be 1.27 centimeters. Of course, we can always just double check to see how close Wellborn is with that. And I'm all right with that. Almost 1.3. That looks pretty good. So using these ratios, we can find various parts of every one of these triangles. Once I know one ratio, I could use that to find all the others. That in combination with Pythagorean theorem. And at this point, I have pretty much everything I need to know. I would need to get everything here. I would just need one of the sides for this triangle, and I could get the rest. So for example, if I measured, well, this side, we'll say, from here to here, I should be able to get the rest without measuring. So if I measure these, this to be almost exactly 11, so 11 centimeters, from here to here, you should be able to now get this side and this side as well. So using ratios to solve triangles is important. There's a little bit in the next exercise that I want you to work through and kind of discover on your own. And then we'll move on to naming some things as we go. At this point, you want to work on the exercises for this and then proceed on to the next video after that.